Alright then, the last part of the graphing of log functions. Here we have a natural log. Y is equal to natural log of x plus 1. We're going to first graph y is equal to ln of x, natural log of x. Table value, here we go. In exponential form, this is written as, well, log e of x, is it not? And so the question is then e to the what power? Then I'm going to put in some numbers. So e to the what will give you a 1. So I want that x to be 1. And the question is, and the answer is, it has to be a 0. Then the next question is, e to the what will give me, well, we've done this before, 2.718. And of course, that means this has to be the 2.718. Then the exponent is going to be 1. And that's enough. Here we go. So now we have y and the x. The first coordinate point is 1 and 0. 1 and 0. Next one is approximately 2.718. 1, 2, 3. So around here somewhere. Okay? Then the y value is going to be at 1. There it is. And you can see right away the behavior of this line is going to go something like, and the asymptote is going to be at 0. But wait. Remember the general form of the logarithmic function? The h is going to determine the vertical asymptote. In this case, the h is -1. So, the asymptote now is going to be at -1. So here's -1. And that means the entire function, the line, is going to shift to the left. And so the new line should look something like that. So what's the domain? What are the x values of this function? If you were to use a table value, x will get closer and closer to -1, but never being a -1, so domain x has to be greater than -1. And what's the range? What's the y value of this function for all the numbers you plug in for x, which is greater than -1? Well, it has to be, it could be any real numbers. Okay, so now, why don't you try graphing this guy? Yeah, you're looking at that h value, aren't you? So now you said, all right, now that's a common log. Since there's no b value, it's a 10, and it's positive. Okay, and so here we go. Let's use a table value here, and then graph the initial y is equal to common log base 10 of x. So here's my x and y. So if I were to write this into an exponential form, I would write it as 10 to the what power will give me a number that I want. So the number I want right now is going to be 1. How would that x become 1? Well, then the exponent has to be 0. Boom. How about if I want that to be, well, suppose I already know that I want it to be -1 here. What would happen to that one then? Then this is going to be 1/10. And to make that happen, I need my exponent to be -1. And no, I'm not going to put a square in here and make that into 100. That won't fit the graph. So, I could already start graphing this guy, at least the initial graph, before the horizontal shift. So, if the x is 1, y is going to be 0. There it is. If x is 1/10, let's say around here, y is going to be -1, right there. So initially, my asymptote is going to be, well, x is getting closer and closer to 0, but never. So initially it's going to be x is greater than 0. However, look at this. Remember the value h, the inverse of -2 in this case, is telling you it's going to shift twice, 2 to the right. So my asymptote, which was 0, is now going to be 1, 2 over here. as a result, my coordinate point 1 and 0 is going to be 1, 2 over here now. And whatever this 1/10, which is -1, is going to be now over here as well. So my new graph is going to look something like this. And my domain now is going to get closer and closer to 2, but never a 2. So x is going to be greater than 2. And what's my range? For any number that I put in that is greater than 2, my range, y, could be any real numbers. I hope you're starting to see a pattern here. So now you, for the final time, try this guy. Alright then, so now you said, okay, I'm going to just go ahead and do a table of value. I got the drift. And I'm going to make that into an exponential form to give me an idea of what input and output should be. So let's say 5 raised to what will give me the initial x. And I want that to be 1. So how does x become a 1? Only if the exponent is 0, or the y. And then I also want it so that it's going to become a 5. How does that become a 5? Well, then the exponent has to be 1. One more just to give me a better visual. 5 to the what power will give me, make that into a quotient, 1/5, if this is -1. Let's graph that. Here we go. So there it is. This time a little miniature version. So x is 1, y is 0. There it is. If x is 5, 2, 3, 4, 5, y is 1. There it is. And initially, the asymptote is 0, so it's going to look something like this. However, what's my horizontal shift? It's going to be -4. So 1, whatever 0 was, now it's going to be 1, 2, 3, 4. Here's my new asymptote. And all the coordinate point is going to be over on that side. 1, 2, 3, 4, right here. So it's going to look something like this now. Oops, there was a little bump on the paper. And my new domain, my input is going to be, it's getting closer and closer to -4, but never. So all the number that's going to be greater than -4. And my range, for whatever input I put in for greater than -4, my range could be any real numbers. Whew! That's it with the graphing. Sayonara, baby.